What's up, everyone? How are you all? It's Sean with Create Your Lifestyle Academy. And in this episode of Beyond the Bonds, episode 3, we are going to talk about matter and energy. So I'm going to define matter and energy. All right, so matter is any substance that has mass and occupies space. Energy is a quantitative property given by the ability to do work or transfer heat. I didn't feel like writing all that out for energy, so I just wrote that. I'll write it out. So, I've introduced some terms just to expand on what we've already talked about in this series. Substance has mass, and mass is given by the SI unit of gram and the volume unit of liter. And energy is a quantitative property in the form of the unit joule, Joule. And so we're going to expand on these terms some more, beginning with kind of giving the classifications of how substances can manifest. And just to clarify, we're going to define what a substance is. A substance is an object that cannot be broken down any further and still retain its properties. And so the three types of substances are elements, compounds, and mixtures. And so before we define elements, compounds, and mixtures, I just want to give you an example of a substance. This marker that I have in my hand is a substance. Right? Because I really can't break it down any further and have it still be a marker. I could cut it in half. I could burn it. But it wouldn't be a marker anymore, right? Exactly. And so these are the classifications of a substance. And I'll define them right now. So an element is compositionally made up of one atom type. So, elements are compositionally made of one atom type. Compounds are made of two atom types, two or more atom types actually, that are chemically bonded. And mixtures are made of two or more substances not chemically bonded. And they can be classified as either homogeneous or heterogeneous. And so, example of an element would be hydrogen gas, which exists diatomically. And an atom, I've introduced a new term, right? So an atom is basically the smallest part of an element that can exist while still retaining the properties of that element. So it's even smaller than a substance at large, right? Substance is more macroscopic, and atoms are more on a micro level that we're talking about. And so compounds are comprised of two or more elements. An example would be water, which we'll see many times because water is really, really cool. And so water is given by the bonding of hydrogen gas and then oxygen gas, which are diatomic, meaning that there's just two atoms bonded with the same atom bonded with itself, but it's still not considered a compound because it means two or more different elements. Two more different atom types chemically bonded. So it's not an atom. It's not a compound. So basically hydrogen gas, oxygen gas form to make water, and that's a compound. Water is given by the formula H2O, two different elements, bada boom, bada bang, you get it. Mixture can be considered heterogeneous, which means that the different substances that comprise the mixture aren't, the different substances that comprise the mixture stand out on its own. For example, Chex Mix. I love Chex Mix. It's really like my favorite chips. It's like pretzels, goldfish, those little chip thingy things, and marshmallows, M&Ms, raisins. It's really good. But those things can be picked out on its own, to be on their own. And so Yeah, pretty much what I just said. Whereas homogeneous mixtures, such as sugar water, can be mixed together and make it seem as if they're one substance, even though they're really not. And so this brings us to, how do we characterize and get more information about substances? Better yet, we can say, in the context of static, meaning an isolated moment of time, and then over a continuum of time, how did these substances behave, right? And so basically we're trying to see properties and changes that occur. The former being static and the latter being more dynamic. So I'm gonna write that on the board. And we define properties and change in two categories: physical and chemical. And a physical property is a property that can be observed without sacrificing the compositional integrity of the object or the piece of matter that we're observing. And we can also change that matter or substance without affecting it compositionally. So physical properties and change, compositional integrity is maintained. So for chemical properties, a chemical property cannot be observed without sacrificing the compositional integrity of that substance. And so, how do we know? So for example, examples of chemical properties are: is it flammable? Flammable. Is it toxic? Is it reactive? Can it be oxidized? Physical properties are things like, for example, once again, color, density, volume, mass. So we don't have to destroy or change what we're looking at in order to see if these things are valid for physical, but we have to change the composition for chemical. And that's why chemistry is so cool. This is where we get to chemical, right? It's really cool. And this really segues into things such as how matter interacts on a microscopic level. And so basically, I told you earlier in this video that an atom is the smallest form of an element that can exist while still retaining the properties of that element. Yet, there exist subatomic particles, particles even smaller than atoms. And the way these subatomic particles interact gives rise to the chemical changes that we see on the macro level. So if I see something burning, it's because these subatomic particles are moving around and changing, which changes the composition of the substances that we originally started with at a later time. Point being, this gives rise to energy in some cases. Well, actually, it let's see. Basically, what I'm trying to say is that this interaction, energy plays a major role because these atoms are colliding with each other and subatomic particles are moving. So there is energy at play. There is no change without some form of energy. And really quickly, I'm just going to throw in there without being smooth: conservation of energy and mass. Basically, these two laws state that mass can neither be created or destroyed, and energy can neither be created or destroyed. They can only take on different forms. And so when we talk about reactions and how substances react with each other, this becomes really important, because if you don't adhere to these laws, you're not doing it right. I mean, it's not rocket science. Basically, don't try to just fabricate things out of thin air. Spontaneous generation is a miseducation. Spontaneous generation is a miseducation. And so, like I said before, we'll see how these interactions play out. Energy is basically the end game of matter interacting. This is what we want, because energy is what's powering the iPhone that's shooting this video. Energy is what's powering me to be even alive. Energy is powering this light. And so, to conclude this video, energy is the end game. And there is a systematic way that we're going to go about there's a systematic way that we're going to go about learning about the different types of energy and how we can get to that energy. And we're going to talk about those in different videos, beginning with the history of atomic theory, and then we'll move on to reactions and how you can control reactions. So be on the lookout. Once again, Sean with Beyond the Bonds. In this video, we talked about matter, any substance that has mass and occupies space. And we talked about energy, which is the ability to do work and transfer heat. Work is more so on a macro level, and heat has to do with the energy of the molecules. And then we talked about the different types of matter, physical properties and chemical properties, and physical changes and chemical changes, which gives rise to the fact that we cannot find out any chemical information without sacrificing or altering the integrity of that substance. And this is why we are so interested in chemistry on a micro level, because we're concerned about the behavior of the particles that comprise the substances we observe. So once again, Sean with Beyond the Bonds. Thank you for your time. See you next video.